Alrighty, it is NTI day 24. Let's just jump into the video this morning. So NTI day 24, the name of the lesson is a tangent angle. A tangent angle. So again, you're going to have a Google Doc with a bunch of blank sections. You just need to fill in the blank sections based off of what I do here today, and then you'll have a couple exercises to attempt on your own. So let's look at the bell ringer. The bell ringer, we got a circle. It's got points A, B, and C. Hopefully by now, hopefully by now, we know what central angles and inscribed angles are. So a central angle is an angle inside of a circle that intersects, so like the two legs of the angle touch two different points of the circle, B and C, and the vertex of that angle is the center. That's why it's called the central angle. It's because this angle stops at the center of the circle. An inscribed angle is an angle where the vertex is on the edge of the circle itself. So BAC is an inscribed angle, and BOC is the central angle. Inscribed, central. And we're going to just, so the bell ringer is a review as to why these are, why these two angles, or I guess how these two angles are related. So if the measure of arc BC, good Lord. Keep yawning. If the measure of arc BC is 60 degrees, so here's arc BC, so I go from B to C, so the arc is just this little sliver of the circle there. If this is 60 degrees, let's answer what is the measure of angle BOC and BAC. So let's start with BOC. The measure of angle BOC is equal to, well, arc BC is 60 degrees, and we know that a central angle is the same exact measure of the arc that it intercepts. So BC is this arc. The central angle touches that point BC, so that means this arc is the same as that angle. So if the arc BC is 60 degrees, then the angle BOC, the central angle, is going to be 60 degrees as well. And then if you remember, there's a special relationship between the central angle and the inscribed angle. If both angles are intersecting the circle at the same point, BC, I'll call that theta central, I'll call this theta inscribed. So theta C was 60. So what's this angle of the inscribed angle? Well, it's just the central angle divided by 2. So is equal to 60 divided by 2. So the measure of angle BAC is 30 degrees. So this was just this is a review of stuff that we've done. Let's go on and jump into the notes section. And guys, if you have questions on any of this, I've been turning Google Meet on. All you gotta do is just click on the link and pop in there and say, "Hey Hardy, will you explain this for me real quick?" And that's what I'm there for. So we'll define a couple of things, and I know we've defined most of these before, probably all of these before. Actually, I know we've defined all these before, so this should be review. A tangent line, or I guess just tangent, is a line that intersects a circle at exactly one point. So you got your circle, a tangent line is just going to come out through here and just barely clip it. That's a tangent line. It intersects a circle at one point. That point P, is called the point of tangency, which makes sense, right? The point of tangency is the point where the tangent line intersects the circle. These next two definitions they have a lot in common. So a chord is a line segment connecting 2 points on a circle. So just basically, if you have a circle, A chord is just a line segment that just goes end to end on a circle. It could be that, it could be this, it could be that. So a chord is a line segment that just connects 2 points on a circle. A chord becomes the diameter, the full length across a circle, whenever it passes through the center of the circle. So if a chord passes through the center of the circle, that means it's the diameter. It's going the full possible length. And then very closely related to a chord is a secant. So a chord is just a line segment, meaning it starts here and it stops here. A secant line is a line that intersects the circle at 2 points. So it goes, so these are examples of chords all in here because they start and stop inside the circle. A secant line would just be, and again, the way that I think it'd be easiest to remember secant line is just whenever you're playing a battle royale game like Fortnite or Apex or Warzone or whatever it is. If you're playing a battle royale game, you'll always start by, the plane is going through the map, and like you have this first storm circle. We'll just picture, if this is the distance that your plane is traveling across the map, it's creating a secant across the circle. So here's a secant line. It's a line that intersects the circle at 2 points. There is a special relationship between tangent lines and secant lines, and that's basically all we're focusing on today. Is this? There's a special relationship with the angles that secants and tangents form. I would encourage you to look on the notes for a better picture. This is just it's early, guys, I'm sorry. This is just a kind of a scribble. It might be hard to see. So look at your notes on Classroom, like the PDF version, to really understand or like to get a bigger picture. But there's something that exists called the tangent secant theorem. What the tangent secant theorem says, and I wrote this down for you on your notes. The angle formed by the tangent line, the angle formed by this tangent segment and the chord angle is going to be 1/2 of the angle of the intercepted arc, which is supposed to be this y degrees. So basically, you have this line right here. This is my tangent line, and it intersects right here at this point of tangency. Okay, so if I have a chord, this chord could be here, this chord could start here and go, but if I have a chord that connects to, or if I have a chord that intersects that point of tangency, you see that it forms an angle. This angle is x degrees. X degrees, so this angle, x that forms, is simply 1/2 of this arc length. So remember, not arc length, arc measurement, So arc length is something different from the measure of an arc. The measure of an arc is in degrees. So this arc from this point to the point of tangency is y degrees. The angle formed from the tangent line and this chord is x degrees. There's a special relationship between these two angles, or I guess these two degree measures, that says x degrees is equal to 1/2 times y, or you could say x is equal to y divided by 2. So when I say x and y, we're looking at these x's and y's here, where y is the measure of the arc, and then x is the measure of the angle that forms when you connect a chord to the tangent line at this point of tangency. We'll do some examples to make this a little more concrete.